Hi. So here in this question what we have is consider the arithmetic progression 3, 7, 11 and so on. So this is an AP whose first term is 3 and the common difference is 4 plus 4. Okay. Now let an denote the sum of first n terms of this progression. Okay. So a1 is sum of only one term, a2 is sum of first two terms, a3 is sum of first three terms. Then what is the value of 1 by 25 times of sigma n is from 1 to 25 an. So what about the sigma an? This essentially means a1 plus a2 plus a3 so on till 25. So what we need to figure out is we need to figure out sum of AP, sum of one term of an AP plus sum of two terms of an AP, sum of three terms of this AP till sum of 25 terms of this AP. Okay. So now what we'll have to do is we'll have to generalize the sum first. Obviously it's not possible to calculate each of these sums separately and then manually add them. That's going to be a very lengthy exercise. So let's try to generalize the sum first. We know sum of n terms of an AP. So there's a formula, right? The sum of n terms of an AP is n by 2 into twice the first term plus n minus 1 into common difference. This is the formula that we would remember from the theory part, right? So applying this formula over here, the first term is 3. The common difference is 4. So generalizing sum of n terms will be n by 2 into twice of first term 3 plus n minus 1 into common difference of 4, right? So let's try to simplify this. This 2 into 3 is 6 plus 4n minus 4. Okay, n by 2 we have. So here we have 6 minus 4 is 2 plus 4n into n by 2. Taking 2 common, we have n into 2 into 1 plus 2n by 2. 2 gets cancelled out. So we have n into 1 is n plus n into 2n is 2n square. So this expression when simplified is n plus 2n square. So the sum of n terms of this AP is n plus 2n square. Now this whole thing simplified is this effectively. So now what we have is we have to calculate a1 plus a2 plus a3 till a25. We'll take care of this 1 by 25 at the end. Let's just calculate the value of this part first. So a1 based on this formula will be 1 plus twice of 1 square, putting n equals to 1 here. Putting n equals to 2, we get a2 will be 2 plus twice of 2 square. Similarly a3 will be 3 plus twice of 3 square, and this will go on till a25, which is going to be 25 plus twice of 25 square. Okay, these are the values of a1, a2, a3 till a25. Now if you add all these terms, what we need to calculate is the sum of all these terms on the left hand side. So if you add them, what you can do is you can add these terms separately and you can add these terms separately. This is sum of first 25 consecutive natural numbers, and here if you take common 2, apart from 2 what you have is sum of squares of first 25 natural numbers. So sum of all these will be 1 plus twice of 1 square plus twice of 2 square, so on this thing. So taking just the first terms together, we have 1 plus 2 plus 3 till 25. And from the second number of each of these terms, if we take 2 common, we'll have 1 square plus 2 square plus 3 square, so on till plus 25 square, correct? So now this is sum of first 25 natural numbers. So sum of first n natural numbers, we know the formula is n into n plus 1 by 2. And this is sum of squares of first n natural numbers. So sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. So using this formula over here, we substitute n equals to 25. So this becomes 25 into 26 by 2 plus twice of putting this formula over here, n which is 25 into n plus 1 into twice of n plus 1 by 6. Okay, fine. So what we have here is 25 into 26. Now 25 square is 625. So 25 into 26 will be 625 plus 25, 650, and half of 650 is 325. Okay, so this term here is 325. Okay, since we had to do 1 by 25 at the end, so let's actually use that here. That will be better instead of doing calculations, right? So now we need to calculate 1 by 25 times of this sigma. So multiplying 1 by 25, this 25 gets cancelled and this 25 gets cancelled. So, and this 6 goes by 2 3 times. So we have 26 by 2 plus 26 into 51 by 3 remaining over here. Now again taking 26 common, 26 by 2 is 13 effectively, and 51 by 3 is 17. So we have 13 plus 26 into 17 over here, and taking 13 common, we have 1 remaining here plus twice of 17. Twice of 17 is 34. So we get 13 into 35. This is what we get. So 10 into 35 is 350 plus 3 into 35 is 105. So the sum comes out to be 455. So the required answer is equal to 455. Hence the answer here is option C, 455. Thank you.